Hello, welcome back. I am with the second part of the revisionary MCQ series on statistical mechanics. We will try to cover 150 plus question in this series. Let's start. Here question number 11. It talked about Fermi Dirac distribution. We already know that the distribution function for Fermi Dirac is f of E is equals to 1 over exponential to the power E minus EF upon KB T plus 1. Listen, if EF is the Fermi energy, which of the following is true? This states that if E equals to EF, if we use E equals to EF, then these factors become 0. Then we have 1 over E to the power 0 plus 1. This is equals to 1 over 1 plus 1. This comes out to be 1 over 2. Hence the right answer for this question is option number B. We have question number 12. It asked about Gibbs paradox and asking about the missing factor in Boltzmann formula. If we divide Boltzmann formula with n factorial, then we get the Gibbs paradox. Hence the right option for this question is option number D. Question number 13. Electronic contribution of specific heat varies linearly with temperature for. This electronic contribution for specific heat CE is proportional to T, linearly depend on T for 1D, for 2D, for 3D, for all Ds. And the right option is D. Question number 14. If Z be the partition function and beta equals to 1 over kBt, try to answer before I put the right answer. Here the partition function is given. We have to give the option for the average energy. Average energy equals to minus partial over partial beta of log of Z. The right option is B. Which of the following plots correctly represent variation of average energy of n spin-half isolated Ising magnets kept in magnetic field and maintained at temperature T? If we look for this, we have a clear-cut graph like this. For a Fermi gas of n particles, in 3D at T equals to 0 Kelvin, means at low temperature, the Fermi energy EF is proportional to. We have a clear-cut formula for Fermi energy EF, and that is equals to H cross square upon 2m 3 pi square n whole to the power 2 over 3. If we need to find only the proportionality, then EF is proportional to n to the power 2 over 3. Right answer is option number A. Here a system of n non-interacting classical points particle is constant to move on the two-dimensional surface of a sphere. Here the number of particles n and the dimension is 2. Degree of freedom equals to 2 into n, which is equals to 2n. And according to the equipartition theorem, we have each degree of freedom contributes half kBt, and this is the 2 degree of freedom, it contributes 2n into half kBt. 2 gets out, we have n kBt. The right option for this question is C part, n kBt. The total energy per particle of a collection of free, the right option for this question is A. This contain very lengthy calculations. I will skip that calculations over here. Question number 19. The wave function of two identical particles in state n and s are given by this and this. The particles obey Maxwell-Boltzmann distribution. If it obeys Maxwell-Boltzmann distribution, then the state of combined two particle system is expressed as, these are independent, then the state is described by the linear product of the wave functions. Right answer is option number D. Choose the correct alternative. Do it by yourself. And answer the question number 20 in the comment box. Question number 21. Gibbs paradox arises due to distinguishability of classical particles. We have question number 22. When an ideal gas can be treated as an ideal quantum gas can be treated as ideal classical gas. Quantum gas is treated as classical when de Broglie wavelength is much smaller than interparticle distance. So the right answer is B. Question number 23. Which of the following statements true for the black body radiations? For this question, we should know about the graph between energy and the wavelength. Here is the graph between energy and the wavelength. If this is the lambda, this is the u. We have peaks like this, this. This peak is for, and this is lambda. This peak is for lambda 1, lambda 2, sorry. T1, T2, T3. This peak, this peak, this peak. T1 is for lambda 1, T2 is for lambda 2, T3 is for lambda 3. Clearly T3 is greater than T2 is greater than T1, and lambda 3 is greater than lambda 2 is greater than lambda 1. Question number 23. The right answer is A part. The number of states for a system of n identical free particles in a 3-dimensional space having total energy E and del E. This is the right answer. A system of n non-interacting and distinguishable particle of spin 1 in a thermodynamic equilibrium. The entropy of a system is, we know that the number of microstates omega equals to three to the power n. Then entropy is given by S equals to kb log of omega. On solving, we get log omega log kb log 3 to the power n. Then we get n kb log of 3. Where is n kb log of 3? D option is the right answer. D is the right answer. It is necessary to apply quantum statistics to a system of particles if the particles are interacting. Two particles are said to be distinguishable when average distance between them is large compared to their wavelength. For an energy state of photon gas, the density of state is proportional to. For this, the right answer is e की power 1/2. Density of state for a photon gas is e to the power 1/2. The free energy of photon gas enclosed in this we have to find the chemical potential. For the chemical potential, we have a formula, and that is mu equals to 1 over beta partial over partial n of F. Here F is the given, is the minus. Mu is the chemical potential. If we see over here, this is the derivative with respect to n, and n is missing, so it should be the 0. The right option for this question number Hamiltonian, is given. Then the corresponding the partition function of this system. The partition function is z equals to z, that z due to E into z into V, z due to E. Hydrogen molecules are in thermal equilibrium at a temperature here it asked for V most probable. Comment down the answer of this question. The correct answer. The average energy per particle at T equals to 0 for the Fermi gas. The average energy, always remember, EF equals to 3 over 5. E is equals to 3 over 5 EF. What? E is equals to 3 over 5 EF, average energy. Question number 33. The right answer is B. Question number 34. The right answer is B. Question number 35. Here is a question, and we need to find the partition function. It contains long calculation. I will skip for it. If you find it, do comment the right answer. Question number 36. This is the right answer. This also involve lengthy calculation. Question number 37. The right option for this question is A part. Question number 38. It asked about the van der Waals gas equation, that is P into V minus B n equals to n kBT. Consider a two-level quantum system. Question number 39, question number 40. These involve lengthy calculations. The right option for 39 is A and the right option for 40 is B. And the right option for 41 is D. Question number 44. The mean number of photon in an energy state E equals to omega. Mean number of photon n, which is equals to 1 over e to the power beta e minus 1. Beta equals to 1 over kBT. Question number 47. In a gas, relative magnitudes of the most probable speed, average speed and root mean square speed. According to the Maxwell law, we have V root mean square is greater than V average is greater than V most probable. So the right option is A. If you are interested in the specific value, if it is 1, it should be 1.128 and it should be 1.224. Question number 48. Question number 49. For this we have VRMS equals to under root 3 RT upon M and VP equals to under root 2 or T over M. We have to find Vp in terms of VRS. For this, we have to multiply by 2 over 3. The right option for this question is B. According to Maxwell's laws distribution of velocities, the most probable velocity is, we have the relation, clear relation. I already told you Vrms is greater than V average and it is greater than V most probable. Ideal gas, mean transitional kinetic energy K dot E 3.2 kBT. This is the question. It asked for the root mean square, average speed and most probable speed. Again we know root mean square is greater than all, and the correct option for this should be D. That is 1 is to 1.128 is to 1.224. We have to choose the incorrect statement. 54. Photons are the boson. This is incorrect. This is the right option. average number of photon. This should be T cube. Consider a system of two identical particles, each of which can be in any of the three single particle states. The number of states of the system are possible in Bose-Einstein statistics. We have for the Bose-Einstein statistics, W equals to I running from 1 up to ni plus gi minus 1 factorial divided by ni factorial gi minus 1 factorial. Here we have ni equal to 2, number of particles, and state gi equal to 3. ni equal to 2, gi is equals to 3. We have to use it over here. The right option then comes out to be 6. Which statistics will apply to deuteron and alpha particle? The average energy of an electron in metal at this is 3 over 5. The pressure for non-interacting forming gas with internal energy U at temperature T is directly odd. P is equals to learn it. 2 over 3 U over V. In Fermi-derived statistics, the volume of phase cell is h cube. We have solved it earlier. The right option is 6. Entropy of photon gas is proportional to T cube. This is the result of direct formula. No heavy calculations required. And that formula is EF equals to h cross square over 2m three pi square n over v or raised to power 2 over 3. The common between classical and quantum mechanical fundamental distribution function is they all depend both on energy and quantum defining states. Thanks for watching. If you find it helpful in any ways, kindly let me know. If you want part 3, do let me know. I will cover the remaining 60 plus questions. More 50 plus questions. Thanks. Have a nice time.